T-minus 10, 9, 8, 7, 6, 5, 4. Go for main engine start. 3, 2, 1, 0. And ignition and liftoff of the Atlas V with the Solar Dynamics Observatory.
SDO, the Solar Dynamics Observatory, launched on February 11, 2010, and has been watching the sun for the last 10 years, providing key insights into what drives the sun's activity, including the space weather that our astronauts and spacecraft must travel through. During that time, it has witnessed incredible solar events and enabled scientists to make many groundbreaking discoveries about the sun. Here are some of the highlights. In 2011, scientists spotted a special kind of ripple on the sun called Kelvin-Helmholtz waves, which look like curling ocean waves. They are also present on the Earth, but aren't the size of the United States. On June 7, 2011, SDO spotted a huge eruption of plasma on the sun. This was the first time such a large event had been captured in such fine detail. 2 months later, on August 9th, SDO observed one of the most powerful flares of this solar cycle. Flares are intense bursts of radiation caused by the release of magnetic energy. SDO records in many different wavelengths, including one tuned to some of the hottest parts of the sun, allowing it to see the full extent of these solar explosions. On December 15th, Comet Lovejoy seemed to survive a close pass of the sun, but broke apart a few days later. In 2012, scientists used SDO's wealth of information to create a new and impressionistic way to further understand temperature change on the sun. On June 5th, Venus transited the face of the sun, an event so rare it won't happen again until 2117. In July, SDO's high-resolution and rapid imaging cadence captured a beautiful solar loop where hot plasma condensed out of the atmosphere, or corona, and stuck to the strong magnetic fields pushing through the surface. On August 31st, the sun had a huge and beautiful prominence eruption that instantly became iconic. Early in 2013, SDO imagery helped astronomers see the early formation of a coronal mass ejection, or CME, and the reconnection events that result in solar flares. CMEs release giant plumes of material from the sun that speed across the solar system. They can interact with Earth's magnetic environment and are hazardous to spacecraft and astronauts. The sun was very active in September and October, first forming what almost looked like a canyon and then crackling with flares and CMEs for a week. Comet Ison made its way around the sun on November 28th, Thanksgiving Day, but unlike Lovejoy, it broke apart immediately. The sun remained active in 2014, with many beautiful prominence eruptions and bright flares. SDO worked in tandem with the new satellite, IRIS, to help study these flashes. On December 19th, just in time for the holidays, the sun put on its final light show of the year. The sun has a cycle of activity lasting an average of 11 years, called the solar cycle. 2015 marked the beginning of the decrease in this cycle, with fewer flares and eruptions. On May 10th, 2016, SDO saw another transit, this time from Mercury. It looks much smaller because not only is the planet smaller than Venus, it's also farther away from Earth, where SDO is orbiting at 22,000 miles above the surface in a geosynchronous orbit. The solar cycle had its last gasp of activity in 2017. In July, a large sunspot made its way across the face as the sun rotated. Then in September, a final burst of flare activity, including the strongest flares since 2001, exploded off the sun. Since this activity, the sun has been pretty quiet, sinking into the lowest point of the solar activity cycle. Scientists were still able to go back through old SDO data and discover a new kind of explosion called forced magnetic reconnection. On November 11, 2019, Mercury transited across the sun again, this time with a much more sedate backdrop. SDO scientists are aiming to continue watching the sun for at least another 3 years, and the spacecraft could even last another decade. During this time, it should witness the rise of the next solar cycle and an increase in solar activity. Without a doubt, SDO's last 10 years changed how we looked at and thought about our nearest star. Who knows what the next 10 might